Let's look how to find the trig values for any point. Now when we talk about any point or any coordinate, this can be something that is not necessarily on the unit circle. So for example, maybe we are given the coordinate 3, 4. And so with the coordinate 3, 4, you can see that this is not one of our special coordinates we've been working with on the unit circle. So it's not a 1/2, root 2 over 2, root 3 over 2. So this right here is floating somewhere in the first coordinate. Right? And then there is a circle that moves around it. All right? So there's some sort of circle where this coordinate is sitting as a point. And if we take a line from the center, we can talk about this theta and find the 6 trig functions for this coordinate. So we don't need to know what the actual theta is. We don't need to know if it's a 30 degrees, 45, 27. It doesn't really matter what this theta is. We still want to find the trig values for the angle that it creates with the x-axis, which is always our initial side, and the coordinate, which we call our terminating side. All right, so think about this representative triangle I've sort of sketched inside here. And I'm going to draw it a little bit larger so we can see and label. And so this is our theta again. And if this is the coordinate 3, 4, that means along the x-axis has a value of 3, and along the y-axis has a value of 4 to be able to get to that coordinate up here. So what we need to do is we need to use the Pythagorean theorem to find this hypotenuse, because you can't use just the x and the y coordinates as sine and cosine when you are no longer on the unit circle. So that's going to be the first piece. All right, so 4 squared plus 3 squared. Again, that's going to be the square root of 25 or 5. So then I can label that side of my triangle. And now I can find my 6 trig functions. So now I can find the sine of this theta, cosine and tangent. And then of course I want to be able to find their reciprocals, which is cosecant, secant, and cotangent. So now based off of this represented triangle for this coordinate, I can look at all 6 trig functions. So sine is 4/5. Right. Cosine is 3/5. And again, we can see that tangent is going to be opposite over adjacent, which is 4/3. Or again, if I look at the y over the x and cancel out the denominators, the numerators create my fraction. And then I can reciprocate all of these. And so that's going to be your technique for finding your trig functions for any point, is to think about where the point sits on the xy axis and draw a representative triangle labeling the sides. Use the Pythagorean theorem to find the hypotenuse, and then identify the 6 trig functions. Now you need to be careful when you are in different quadrants. For example, if I give the coordinate -5, 12. Okay. So this coordinate is in the second quadrant. If I were to think about drawing that again, -5, 12 would be somewhere in the second quadrant. And so when you draw a triangle, right, and you label the central angle theta, right, again, you have to be careful on how you're going to label these. Right? This is some sort of circle, again, where this point is a coordinate. And so let's draw that triangle again. And now, again, like I said, you need to be super careful because the x value is -5, and you need to make sure you attach the negative to that side to show that going from the center to the edge is going down the left or the negative side of the x-axis before the vertical is 12. And so that's the coordinate up there. Now, hypotenuses are always positive. It does not matter which quadrant you're in. When I take the square root of 12 squared, I need to remember that the negative 5 has to be squared. So I should not have any kind of negatives in here. And this should never be negative. And so we've got 144 plus 25. And so that should be 13. So now when we find our 6 trig functions, since one piece of our coordinate is negative, some of our trig functions will be negative and some will be positive. But you can also remember the ASTC that we talked about before to remember which ones that will happen to. So in the second quadrant, right, when we label our ASTC, sine and its reciprocal are going to be positive. All the other the 4 trig functions are going to be negative. So again, I can look at my triangle this way and see sine is opposite over adjacent, opposite over hypotenuse, and then just reciprocate it automatically. Cosine is adjacent over hypotenuse, and now you can see that that value is going to be negative, which also makes your secant negative. And tangent opposite over adjacent will also make this negative. Oops, made a mistake. Forgot. All right, let's change those to 13s. That was the hypotenuse. All right, opposite over adjacent, so negative 5 over 12. Okay. So really, you just need to be careful when you think about what the triangle is. You don't always have to draw this little representative, quadrant here. You can go straight to the triangle. You just got to be super, super careful. All right, so let's do one more. Let's make this negative 4, negative 7. And so again, if I think about that, right, that means I'm going to be down here in this third quadrant. And so instead of doing 2 triangles, like this, we could just draw the triangle inside the quadrant. Right. Your theta is always from the x-axis to the terminal side where this coordinate is. And so I like to sometimes, when I'm doing it this way, identify that coordinate. But again, you have to remember, x goes to the left 4, y goes down 7. And so when you label the sides of your triangles, you need to make sure that you put negatives on there. Otherwise, your trig functions are going to be off. All right? So negative 7 squared plus negative 4 squared. All right? So that's going to be 49 plus 16, or the square root of 65. Now, you always need to check to see if your radicals can be simplified, meaning there must be perfect squares if I'm going to change what this looks like. So if I think about numbers that multiply to give me 65, I don't think that I can take anything out of this. All right? I know it ends in a 5, so if I divide this by 5 just to check my perfect squares, all right, I'm going to get 5 and 13 are the 2 factors, and neither of those are perfect squares, which means I need to leave this hypotenuse as the square root of 65. So don't pull anything out of the radical if neither of them are perfect squares. Leave it alone. And then we can identify sine, cosine, tangent. And again, this is down in that third quadrant, which is our t, which means tangent and its reciprocal are the only ones that will end up being positive. All right. So again, sine, opposite over hypotenuse. And I'm writing this kind of small here because you need to remember that you can't have a radical in the denominator. So this really needs to be negative 7 root 65 over 65. And so that's my shortcut. Of course, I didn't show you that I was multiplying top and bottom by root 65. But again, your simplified trick is to leave the negative 7 or the numerator alone, put the radical up top, remove the radical, and what's underneath stays there. Same thing here. I'm going to end up with negative 4 root 65 over 65. And then opposite over adjacent is going to give me 7/4 for my tangent. All right, when I reciprocate that, I'm going to get 4/7. And now for cosecant, I'm going to think about this first one that was unrationalized, so that way I can just flip those fractions. Same thing for the other one, negative root 65 over 4. So take your time, really think about what quadrant your coordinate terminates in. You must draw this representative triangle, labeling theta and the sides that are known to you, and use the Pythagorean theorem and label the hypotenuse before finding your 6 trig functions.